Alright, for this recording, we're going to be looking at question 1. This is question 1 out of 6 questions from this November 2023 question paper. In the description box, I'll also leave links for other questions that I've answered for this question paper. This is paper 1, mathematics level 4. Now, question 1 focuses on complex numbers. This is not the only question. On screen, I only have 1.1. It's a multiple choice question. There's also 1.2, 1.3, and I believe 1.4. So the 1.2 contains an Argand diagram, and then we also have 1.3, or let me just stretch it out, so yeah, right there. Okay, so we also have 1.3, 1.4, and 1.5. So it's a total of 5 questions out of question 1. Alright, but let's start with the multiple choice part of the question. So we are provided with various options as possible answers to the following question. So 1.1 all the way up to 1.5, we're going to have to choose out of the given options. But in order to do that, you'll have to solve the given problems. So in this instance, like 1.1.1, we are given Z1 as being 6 plus 4i, Z2, it's 8 minus 3i. Then they are asking us to calculate Z1 times Z2 in standard form. So the answer is going to be A, B, C, or D. So the best way to answer this question would be to take the Z1 and Z2 and multiply them and get the answer. So Z1 multiplied by Z2. So it's basically an operation of multiplying two complex numbers, right? So we're going to foil. We're going to have to foil in this one. So Z1 was 6 plus 4i. See what I'm doing? I'm putting the expression in a bracket. It's an expression. It's a complex number. When multiplying two complex numbers, you would have to do this. So 6 times 4, I think it's 48. 6 times negative 3i, that's 18i. This 4 times 8. 4 times an 8. 4 times an 8, 32. So that's, yeah, positive 32i. And then the plus 4i multiplying the negative 3i, that's going to be a minus 12i squared. Okay, so here it's going to be a 48 minus, not minus, but negative 18 plus 32. Plus 32, I'm getting a plus 14i, and then a minus 12 minus minus 1, because an I squared is equal to minus 1. So it's a 48 plus 14i plus 12. Adding, I'm getting a 60 plus 14i. 48 and 12 are like terms. So the best or the correct answer for 1.1.1 is going to be B. It's going to be the second one. Alright, for 1.1.2, it's the what is it called? The I properties. The I properties. So we know that an I squared is equal to a minus 1. So we'll have to try to break down the 15, the I raised to exponent 15, to a point where that I can simplify the I. Hopefully that makes sense, but let me show you what I mean. So the I raised to exponent 15 should be split in such a way that the exponent is an even number. So 15, it's not an even number, it's an odd number. So I'm going to do this. I'm going to say I raised to exponent 14 multiplied by I raised to exponent 1. The exponential law that says multiplying powers of the same base, you add the exponent. So I'm doing the opposite of it. Instead of adding them, I'm going to split them into 14 and 1. But by multiplying them together, it's going to bring you back to 15. Now I have one of the i's with what? An exponent that is an even number. So 14 is an even number. What I'm going to do now, I'm going to isolate the I squared. I'm going to isolate an I squared like this. Now, what is 14 divided by 2? That's 17. So when you multiply a 7 by the 2, it's going to bring you back to 14. We then have an I. So an I squared is actually minus 1 raised to exponent 7 multiplied by I. So a negative number raised to an odd exponent, it's always going to be a minus 1. And then I'm putting the I there. So the answer is a minus 1. So it seems like 1.1.2, the answer will be D. It's going to be D. Okay. 1.1.3, the factors of x squared plus 25. Okay. In a high school setting, the x squared plus 25x, I would argue that, or say that, this cannot be factorized, right? But here, this can actually be factored, but factored how? Using complex numbers. Let me say that. Using complex numbers. So A is out of the picture, B is out of the picture, D is out of the picture. The answer will be C. Let me explain. X squared minus 25. So this is this can be factored out. It's a difference of 2 squares. But here we are dealing with a sum of 2 squares. Hence I'm saying in a high school setting you cannot factorize this. But we know better now, right? So getting the factors for this would actually be a 5i, 5i, and a plus and a minus. So taking the C and trying to multiply or FOIL the 2 brackets, it's going to take you back to this, right? So this is a difference of 2 squares. When multiplying, it's going to give you that bracket. I'm cancelling out A, or knocking out A out of the possible solutions, because X, it's definitely not a common factor. And then here, no, I cannot have 2 brackets with the same thingy, same signs. It would mean that this is a perfect square, right? So simplifying the bracket on C, x multiplying x, it gives me an x squared. This x multiplying that plus 5i, it's a plus 5xi. This multiplying this gives me what? A minus 5xi. The minus 5i multiplying the positive 5i, that gives me a minus 5i squared. The middle terms are cancelling out. I'm now left with an x squared minus 5. Wait. A 5 times 5, it's 25. So here we're going to have a 25i squared. 25, and I squared, it's minus 1. Multiplying gives me an x squared plus 25. Ding, ding, ding. Here we go. That's the answer for that one. Okay. So 1.1.4, it's the Moivre's theorem, right? So taking z or z and raising it to an exponent of 3. So the theorem states that the coefficient will be raised to the exponent 3 and the angle will be multiplied by that 3, right? So taking this 5 cis of 60 degrees and raising it to exponent 3, z is equal to 5 cis 60 degrees. We want z raised to exponent 3. So it's going to be a 5 cubed and a cis 3 multiplying 60 degrees. So the answer should be this one, D. So the answer is going to be D on this in this case. All right. So 1.1.5. Well, I think that the 1.1 question, it's actually preparing us for, or what to expect for the following questions, right? Because It contains almost all the concepts that will be discussed or answered in the next session of this question 1. So solve for y in this equation. Solve for y in this equation. Look, the y is the coefficient of the imaginary number. The y is the coefficient of the imaginary number. So let's do some simplification first. So the left hand side is fine, there are no like terms. However, on the right hand side, the 15 and the 10 are like terms. 15 minus 10 gives me a 5, minus 3i. Okay, minus 3i. So as you can see, this 5 and this 5 are equal. We want to know the value of y. So this equal sign is simply saying that the left is equal to the right. So this real part is equal to this real part. And the imaginary part, they should also be equal. So it's the basic premise or basic principle behind the simplification of simultaneous equations in with complex numbers, for complex numbers. So I'm going to take this minus yi. I'm going to say minus yi equal to a minus 3i. You need to take the sign as well as the imaginary part and equate them on both sides, right? So we want the value for y, so I'm going to divide by a minus I. So cancel. Negative 3 divided by negative I, I'm getting a positive. This cancels out that. Negative over negative, it's a positive. So my answer is going to be B in this case. Okay. Any questions that you have, leave them in the comment section. Then we're going to discuss it. Okay. Now I'm going to take this out. Let's go to the next part of the question. So here on 1.2, we are given an Argand diagram representing two complex numbers, Z1. We are not told what the modulus value is. Modulus value is, right? But just by reading off or looking at the diagram, you can read off all the values that you need. So in this case, we have R1 for Z1. And we also have cis angle, alpha, theta. We also have Z2, the second complex number, modulus 2, cis beta. Okay, so all of these values are given on the sketch, right? On the sketch. So for the first one, 1.2.1, they want us to write Z1 in standard form. So Z1 is equal to R1, the modulus 1, cis alpha theta is equal to, what is R1? R1 is the modulus for complex number 1. So it's actually this one. It's the square root of 52 multiplied by cis. Look, I'm writing cos. It's cis of alpha theta, the angle theta. The angle alpha, which is 123.69. 123.69 degrees. So this, or in standard form. So we need to simplify this further. We're gonna say square root 52 open bracket cos 123.69 plus I multiplied by sine 123.69 equal to, okay, then I'm gonna distribute the square root 52 inside the bracket. 123.69 plus square root 52 sine 123 comma 69 multiplied by I. Then we simplify. Square root 52 multiplied by cos 123 comma 69. I'm getting a negative 3,99999. So rounding this off into 2 decimal places or 3 decimal places, we're gonna have what? Basically a 4. Let's get the answer for this one. Sine, the answer is a plus 6i. So this is the answer. Okay, for the next one, I think I can erase this part. Okay, so let's go for 1.2.2. Determine z1 times z2. So z1 multiplied by z2 is equal to, what is z1? That's the square root of 52 cis 123,69 multiplied by the z2. So z2 is gonna be what? It's gonna be z2 complex number 2, so it's square root 8 cis, what's the modulus for this? I mean argument, it's 315 degrees. So we multiply square root 52 times 8, square root 8, square root 52 times square root 8, cancel outside, square root 8. I'm getting a 4 square root 26 multiplied by cis. So look, I'm multiplying 2 polar forms, 2 complex numbers in polar form. So when you multiply 2 numbers in polar form, you're gonna multiply the modulus and add the arguments, right? So with this, we're gonna say 123,69 plus 315 degrees. So the final answer is gonna be a 4 square root 26 cis adding 123,69 plus 315. The answer is gonna be 438, 438,69. But wait. Now on the question they say that we should leave our answer in this form. I mean, we should leave our argument to be between, or the argument should be between 0 degrees and 360 degrees. So what do? Our argument is 438, so it is went past 360. So what do? You take away 360. You're gonna minus the 438.69 by 360. So the final answer is gonna be 4 square root 6 cis, what's the answer? 78,69 degrees. So this is the final answer. All right, now on the 1.2.3 they want us to add the 2 complex numbers now. So 1.2, from the Argand diagram, we're doing operations with the given complex numbers. So the next operation is now to actually add the 2 complex numbers. So we're gonna do the following. We're gonna say 1.2.3 z1 plus z2. This is equal to, we actually have z1 in standard form. On the first question, 1.2.1, they asked us to calculate z1 in standard form. What did we find? We found that z1 it's minus 4 plus 6i. Plus, what about z2? Z2 it's square root 8 cis 315. It's square root 8 cos 315 plus I multiplied by sine 315 degrees equal to minus 4 plus 6I plus, let's multiply these two, square root 8 multiplied by cos 315, answer is 2. And then let's do the same thing with the sine, with sine 315, the answer is a minus 2I. So this and this are like terms, they're giving me a minus 2. This and this are also like terms, they're giving me a positive 4I. So this is the final answer. Now 1.3, another question, the next question. I think just to create some space, I'm gonna remove the Argand diagram because it was only just pertaining to the 1.2. So 1.3 has nothing to do with the Argand diagram. Now 1.3, we are given an expression to simplify. Now use 3 decimals and leave the answer in polar form. So we have this 1 minus I raised to exponent 5 multiplied by 2 cis 30 degrees divided by 12 minus 8I. Okay, so let me highlight the crucial statements here. Simplify the following complex expression and write the answer in this form. Use 3 decimal places. Use 3 decimals and leave the answer in. Wait a minute. Simplify the following complex expression and write the answer in form. Something is not right. Use 3 decimals and leave the answer in polar form. Simplify the complex expression. Okay, okay, now I understand. Now I understand why they are saying this. Now they want us to simplify the complex expression. We have 2 expressions. It's this one and this one. Simplify them first and write the answer in the form. And write the answer in this form. Use 3 decimals and leave the answer, which answer? The final answer, in polar form with the angle, the argument being between 0 degrees and 360. Calculations in rectangular form are excluded. Calculations in rectangular form are excluded. Okay, yeah. Check the mark allocation as well. Let me show you. It's not a difficult one, but I don't want to be insensitive towards this one. I just want to, it's 3 marks. It's 3 marks. It's 3 marks. So in level 4, calculators are actually allowed. They're actually allowed when doing or performing calculations with complex numbers. For instance, the 1 minus I, right? I would have to change this expression, right? Okay, no. Something is not right with this thing. Simplify the following complex expression and write the answer. No, something is not right here. The final answer should be in polar form. Because if you were to simplify and leave it in standard form, it can be done, but it's gonna be a lot of work and not worthy of 3 marks, in my opinion. But in this case, the answer should be left in polar form. So it means that everything should be expressed in polar form. For instance, the 1 minus I raised to exponent 5. The 1 minus I should actually be changed to polar form, right? Because the exponent 5 is signaling or saying to you the Moivre's theorem should be applied here, right? So we have to convert this standard form to a polar form. How do I do that? You can actually use a calculator for this. You are allowed to use a calculator for this, because if you don't, you would have to prepare or draw an Argand diagram and calculate the modulus, calculate the argument, then plug in the values. You see, it's gonna be a lot of work. So what is advised in such calculations would be just to use a calculator for finding or converting from standard to a polar form. So after using my calculator, this is what I got. Let me use white, 1,414 cis minus 45 degrees multiplied by 2 cis 30 degrees divided by, you punch this on your calculator. The answer was what? 14,422 cis negative 33,690. Okay, all it takes is for you to punch this on your calculator and get an answer. If ever you have any questions regarding using your calculator, that black Casio calculator, on how to change complex, to work with or perform calculations with your calculator, just let me know in the comment section. I'll create a video now just to show you how to use your calculator to do calculations in complex mode. Alright, so here we are applying De Moivre's theorem now. I'm erasing this. It shouldn't be 2, but it's 5. It's 5. Now we take this 1.414 and raise it to exponent 5 cis, and then we take the argument, we multiply it by 5 multiplied by 2 cis 30 degrees divided by 14,422 cis negative 690. Here we go. So let's get the exponent 5, the 1.414 raised to exponent 5. I'm getting 5,653 653 5,653. Yes. And then what is 5 times 45? 45 times 5, I'm getting minus 225. So here it's gonna be a cis minus 225 multiplied by 2 cis 30 degrees over 14,422 cis minus 33,690. Alright, so on the numerator I'm gonna multiply the two complex numbers, 5,653 multiplied by 2. I'm getting 11,306. Yeah, and then we add the arguments. So we're gonna have this minus 225 plus 30 minus 195 degrees divided by 422 cis negative 33,690. Alright, then what? I have two complex numbers dividing each other. So what do? We take the 11,306 divided by 14.422. Answer is 0,783. Let me double check. or 784. 784 sys, and then we subtract. The argument, so it's -195 minus 33,690. Okay, so it's gonna be a -195 plus 33,690. Answer is -161.39 31. So here it's gonna be equal to for 3 marks. I've done a lot now. Sys of -161,31. Okay, now here the angle, we are told that the argument should be between 0 degrees and 360. Look at the argument we just calculated. It's -161.31. So in order to get it to be between 0 degrees and 360, we're gonna add 360 to it, so that it becomes a positive value. So the answer 0,784 sys of 198,69 degrees. This is gonna be our final answer. Okay, next one. Where's the writing? Okay, yes, let me open it up, and then let's answer 1.4. So 1.4, they want us to solve for x if the equation it's given as x cubed minus 6x squared equal to minus 34x transpose x cubed minus 6x squared plus 34x equal to 0. Okay, so x here is a common factor. We're gonna take it out. I'm now left with an x squared minus 6x plus 34 equal to 0. So the first solution is 0, or x squared minus 6x plus 34 equal to 0. You may try to factor this one out. You might try to get or simplify the equation by factoring, all to find that you cannot get your factors, right? So the best way to solve for x, more especially here at level 4, would be to use the quadratic equation, because all our quadratic equations, they are mostly giving us what? Complex solutions. So I'm gonna pull out my a value, my b value, my c value as well, 34, and then I'm gonna plug in all the values into the quadratic equation. Minus plus minus b squared minus 4ac over 2a. Then we solve. B, that's minus 6 plus minus square root of minus 6 squared minus 4. What is a? 1. What is c? That's 34 divided by 2. What is a? That's 1. X, that's positive 6 plus minus the square root of. When trying to simplify the expression under the square root, minus 6 squared minus 4 1 34, I'm getting a minus 100 over 2. 2 times 1, that's 2. Alright, so you can see that we have what? A complex solution now, because the square root of a negative number is it's undefined. Yeah, it's undefined. But in our case, we're gonna have to rewrite this as the square root of 100 multiplied by the square root of minus 1. We're gonna split it like this, right? Basic rules. The basic rule or basic principle with SATs. So I'm isolating the 1 and the 100, because we know that the square root of minus 1, it's what? It's I, isn't it? Now x becomes a 6 plus minus, what's the square root of 100? That's 5. Square root of minus 1, that's I, over 2. So these are our solutions. No, I'm tripping. What's the square root of 100? It's 10. Oh yeah, it's 10. It's 10. It's 10. The square root of 25 is 10. The square root of 25 is 5, not the square root of 100 being a 5. Okay, so here it's 10. Square root of 100 is 10. So dividing both sides by 2, or dividing each and every term on the numerator by 2, gives us the following. X is equal to 3 plus minus 5i. So these are the solutions for the above equation. The first one is x equal to 0, and then the second one it's this complex solution. Alright, for the last one, we have a simultaneous equation. Okay, so they want us to solve for x and y in the following equation and express any non-real solutions in the form a plus minus bi for all values where y is element of real numbers. So 1.5, I have 3 minus I x squared y equal to minus x squared plus y plus 4i. Alright, so the first thing I would have to do is remove the bracket, and this I would rearrange it to the following: x squared y then I equal to minus x squared minus y plus 4i. Alright, plus 4i. Now we know that a complex number is written as a plus bi, this being the imaginary part, this being the real part. Okay, so you can see that on the left hand side you have the real part a, and then on the right hand side you have this as the real part a. Now the imaginary part will always have I next to it, right? So with this now being bi as a whole, and this being also what? Bi as a whole, so we're gonna take the a's, the real parts, and equate them, and we're gonna take the imaginary parts and equate them. So I'm gonna take the 3 and equate it to minus x squared minus y, and I'm gonna call this maybe equation 1, and then I'm gonna take the the imaginary parts, and equate them as well. Minus x squared y equal to 4. So what I did, I abandoned the I values. You can take them, no problem, but they eventually gonna cancel out at the end, right? So it's best to just take the b values next to the i's. So minus x squared y, that's b, and then the plus 4, it's also a b. Remember to take as well as the signs. Yeah? Now the next step, this is equation 2. This is equation 2. I don't know how you would approach this one, but in my case I would take the first equation and make y the subject of the formula. So I'm gonna say 3 equal to minus x squared minus y. Transpose the y, it becomes a positive y, minus x squared minus 3. This is equation number 3. Sub 3 into equation number 2. So in equation number 2 we have minus x squared. I'm gonna open the bracket and substitute y, which is equation number 3. So it's gonna be a minus x squared minus 3 equal to 4. We multiply the minus x squared times the minus x squared gives us a positive x exponent 4 plus 3x squared equal to equals to 4, equals to a 4. Now this is going to be equal to a 4. Look, we end up with a alright, anyway, yeah, it's becoming a mess now, but it's fine, it's fine. So I'm going to transpose the 4 to the left hand side. We now end up with a quadratic equation in a way. This is also a this is considered a quadratic equation. This is considered a quadratic equation. I have exponent 4 and exponent 2. So the powers are descending by a factor of 2. So 4 divided by 2 gives me what? 2. So what I'm trying to say is that this is actually in this standard form, plus c equal to 0. This can be treated as a quadratic equation squared. It's 1. It's 1. Let me erase this. Yeah, so this is also a quadratic equation. So when we get to this step, I can either use the quadratic equation again or factor out x squared close bracket equal to 0. So it's gonna be a 4 and a 2. What am I doing now? Oh, it should be 4 and 1 plus 4 minus 1. So the answer is gonna be x squared equal to plus 1 or x squared equal to minus 4. It's equal to minus 4. Alright, therefore taking the square root on both sides, it's gonna be x equal to a plus minus 1, equals to a plus minus 1. Okay, and also taking the square root on both sides, even here it's gonna be an x equal to 2i. Remember, the square root of 4 can be written as square root 4 times square root of minus 1. So the square root of 4 is 2, square root of minus 1, that's I. Plus minus, just like we did with this, because when taking the square root, you need to write your answer as a plus or a minus. So these are the first x values. Now in order to get the y values, we're going to do the following. So the y values, y will be calculated using equation number 3. So for the first one, it's going to be a minus 1. So I'm starting off with the ones for x. So where there's x in equation 3, I'm substituting 1. So it's a squared minus 3. The answer is going to be a minus 4. So even if I substitute the positive 1, I'm still going to get a minus 4. Right? So both the positive 1 and the minus 1 are going to produce a minus 4. And then for the plus minus 2i, so y is equal to minus negative 2i squared minus 3. So this one is going to be minus, what is negative 2 raised to exponent 2? That's positive 4i squared minus 3. Y is equal to minus 4 in bracket minus 1 minus 3. Simplifying this, it's a positive 4 minus 3. Y is equal to 1. Y is equal to 1. So even if I substitute a positive 2i in this case, I'm still going to get the same answer as y equal to 1. Okay, this was a long video, a long discussion, but anyway, I hope you enjoyed. Check the description box for more recording that I've done for this November 2023 paper. For now, I'm signing out, guys. Catch you in the next one. Bye bye.